When I first started experimenting with drones, I went through a lot of iterations of different manufacturing techniques, airframe configurations, motors, autopilots. Many of the drones I flew were based on an X configuration. This design is a spider from Thingiverse. The problem I found with the X configuration is that even a relatively low impact crash, which of course inevitably happens when you're experimenting and trying new things, causes the force on the arm causes this sort of central structure to break. Now, while it might be simple enough to reprint the piece, all of your electronics and the flight controller and the power distribution and everything else are mounted on those pieces, and so it means that even a low velocity crash causes you to strip the drone down and basically completely rebuild. From a reliability point of view, we'd say that the mean time to repair and the associated complexity and frustration is not what we want from that configuration. In terms of the manufacturing techniques, while of course it's fun to design and 3D print the entire drone, just the engineering realities, the carbon fibre of course has all kinds of material properties that are very useful for drones. It's incredibly strong, it's lightweight. So what I wanted to achieve with this project was to try and solve all of the problems and take the lessons that I'd learned on board. So this drone is based on H configuration rather than X configuration, and all the long kind of structural pieces of the drone are done using this 15mm square carbon fibre tube. And so in addition to that, I've just designed and uploaded a whole variety of sort of modular bits and pieces that can be used for combining the carbon fibre tubing in different ways and mounting your flight controllers and GPS antennas and cameras and what have you. So the idea of this project is that the H configuration has a shorter mean time to repair if you do have a crash. It takes advantage of the properties of carbon fibre, and also this kind of modular architecture not only gives you flexibility in terms of how you choose to configure the drone, but it also has the benefit that if you do crash and something breaks, you don't need to reprint and refit major structural bits. Instead, you're sort of talking about if something breaks, it tends to be a fairly small, simple modular component. So we're going to go through the exercise of sort of using this grab bag of modular bits to put a drone together. This is one of the larger drones I've previously built using this modular architecture. Just to run through what some of the pieces are. So there's sort of 90 degree adapters for the carbon fibre tubing. In this particular case I'm using those to realise landing legs together with the feet. Slide on motor mounts. There's a fairing that you can use if you've got sensitive equipment. In my case the flight controller is mounted underneath the fairing. There's also various adapters and mounts, like for mounting the GPS antenna or the radio control antenna. In addition to that, there's an assortment of 90 degree sort of mounting pieces. So for instance, there's one there which has the video transmitter on it. Some of the main pieces are these shelves, I call them, of various widths. So they're kind of general purpose, so for instance here I have one of those shelves which has a payload release servo mounted on it. Likewise the camera or the flight controller are all mounted on those kind of generic shelving. The main structural pieces in terms of the H configuration quadcopter, these pieces, and so that's what sets the width for the airframe and what supports the H structure. So I've got a heavier version and a lighter version of those online, and once you 3D print those and slide the carbon fibre tubing through, then there's just a number of holes that you can drill out and mount with M3 bolts or similar. The battery mounts are a little bit more tricky in terms of course there's a huge variety in the shapes of lithium polymer batteries you might be using. I have a project on Thingiverse, which is a lithium polymer battery mount customizer. And so if you put the dimensions for your battery, then it'll generate an STL that you can print. So for this large quadcopter, the battery is just about the right width that mount sits between the carbon fibre tubing. For the copter that we're going to put together now, the batteries are quite a bit smaller, and so my plan there is to use some of the shelves, and basically they will serve the purpose of bridging between the frame to support this battery holder. This is the basic architecture of the drone we'll put together. Given the 10-inch propellers, the motors can be mounted in relatively close, although of course you do need to make sure that you're going to have clearance of the propellers. That will then enable me to cut that length of the carbon fibre, which will provide the tubing that I need for the rear motors. I've got one of the sections I printed out of white PET, just to make it easier to tell which is the front, which is the back when you're flying. And then there's sort of the battery mount, a shelf for the flight controller, and a few of the modular bits and pieces, and we'll figure out exactly where they all go as we get a little bit further along. The motor mounts are part of the Thingiverse project, so they just slide on to the carbon fibre tubing, and you can fix those with a couple of M3 bolts. The slots in the motor mount are spec'd to take a wide range of different size motors. They're probably overkill for these particular motors that I'm using in this project, but they certainly can accommodate larger motors. I normally print these motor mounts out of nylon, given that it has better material characteristics at high temperature in case your motors get hot. Although for this particular project I just printed these using PET, given I don't expect the motor temperature to really be an issue. Of course, whatever motors, propellers and mounting arrangements you use will depend on what you've got available in your mission profile. It did just occur to me though, the combination of equipment that I've got, the motors have a 5mm shaft, whereas I have T-motor style propellers. Fortunately, as it turns out, I'd previously uploaded a project to Thingiverse, which is adapters so that you can use the T-motor props. So I'll put a screw on to hold that, and hopefully then the motors assemblies will be ready to fly. We've now got something that's looking a lot like an H-frame quadcopter. So the main cross braces and the motors, etc., are all bolted together now. This is what I ended up doing for the battery mount. So using the two shelves as I'd suggested, together with the custom size battery holder. So that just snaps neatly into the frame. There will be a couple of bolts hold that in place. Obviously you want the center of gravity to be somewhere near the center of the airframe so that the load is evenly distributed between the four motors. In this particular case I've got a 4S 5 amp hour battery, so that fits very neatly into the holder, and then I'll use a couple of Velcro strips to hold that in place. So the final step now is just playing around with the other shelves for the flight controller and the radio, the antenna mounts, just to figure out exactly where I want to put those, and then we'll be right to finish putting all of the modular components together. The shelf modules are now attached for the flight controller and any other electronics. With the length of the shelves that I use, the battery is offset by about 10 millimeters from the center, but we can live with that. The next step is just to fit the flight controller and the receiver. Of course, the modular drone hardware will work with whatever flight controller and software stack you choose to use. I'm using a Martech Sys H743 wing, and I'll be using that with Ardu Pilot. So I've just soldered all of the connectors onto that, and I've just got some good 3M double-sided tape that I'll use for fixing that down to the shelf. It's flight day. The build of the drone is now complete. You can see I've got the flight controller mounted, the antenna for the radio control. I haven't wired up the telemetry module yet, but that's not critical for the purpose of the exercise. I also ended up designing and uploading the design for some nifty little 3D printed landing legs, just to help lift everything up out of the grass.
Well, there's a little bit of wind, but it flies. I'm about to hit the go button, send it on an auto mission, on a waypoint mission, and I'll use that data to help calibrate the magnetometer.
Well, that first auto mission didn't quite go as planned. The drone took off and flew very nicely for the first half of the mission. Then it began making a noise and became visibly less stable in flight. So I threw the switch to make it return to launch. During the descent, it was quite unstable, and then it lost yaw control and fell the last part of the descent and hit the ground. So on taking a look, the root cause of the problem, I think, is this counterclockwise propeller had loosened the nylock nut a little bit, and so the prop was just spinning, which is why it was unstable and ultimately crashed. Obviously there's a lesson in there. I know on different motors you can get the counterclockwise, the right hand thread for the propeller, which this doesn't have, but I'll put some Loctite and a lock nut on it. However, just to emphasize that this really comes back to one of the core motivations for this project, that even though it had quite a fall, the only damage that was sustained is one little 3D printed piece. It must have landed on one of the motor mounts. So the 3D printer is going in the next room, printing a new one. But otherwise, there's still a working drone. So I'll get onto the repair and fixing the problem that caused this crash, and we'll be airboarding again in no time. There were no problems with flying the mission the second time. The airframe's fine, the mission executed well in spite of the wind. No propellers fell off this time. Of course, the next obvious step would be to add payloads. The drone has the shelf there where a camera or some other payload could be incorporated. I might not worry about that right now. Really the purpose of this video has just been to introduce this Thingiverse project and the designs I've got for all these 3D printed modular components which fit onto the carbon fibre frame. Out of interest, I actually put this copter as well as the Spider drone on the scales, and I think that in spite of the fact that with this design the electronics is much more accessible, easier to repair, the difference in weight is only a few percent. You know, there's only 100 or so grams difference between the two airframes. Drop a comment if you've got any questions or comments. I'll put all the links into the section below, and happy flying.